there we are. Now all the problems in this video are fixed. It is moving in a Z direction, it is not changing the size, and even the landmarks are not changing the sizes. Hello everyone, welcome back to Whose Computer Science Project. In this video, we are wrapping up the 3D virtual hands. If you are new here, don't worry, I will show you a sample of the project demonstration.
Here we go, you can see a 3D hands and it can actually interact with the 3D objects. So I have those little towers of cubes.
Interested? If you want some more details about this project demonstration, I will put the link of that video in the description below. For those who have seen the last video, you may remember that we have a problem with the hand movements. It worked fine with the X and the Y axis movements. However, when I brought my hand forward and backward, that didn't work. It was just changing the size. Now enough talking, let's jump to the computer and let's get started. So here we are in our Unity projects. But before that, let me introduce something. You may wonder, why doesn't the hand move in the Z axis? And you may remember that we are using MediaPipe, right? And if we are using MediaPipe, we should have Z coordinate for the landmarks, right? Yes, you're right. We are using Z coordinate for each landmarks. Well, I have noticed that the landmark number 0 from the wrist, from the MediaPipe documentation, the Z coordinate of that specific landmark is always equal to 0. Yes, always to 0. And all the other landmarks has a Z coordinate, but they are just referencing to the wrist landmark. So it looks like we are a little bit stuck there. But don't worry, I have figured out a way to bypass this problem. To bypass this problem, we will need 2 points. One is the hand size, and when I say the hand size, it's not the real size of the hand. It's actually the size in pixels seen by the webcam. And the second point will be about finding a relationship between the hand size and the Z coordinate of the whole hand. First point, to get the image size, I have decided to pick up the 5th and the 17th points, because their distance doesn't really change, and we can rely on that to figure out the size of the hands, seen by the webcam. Don't forget that. To do that, we can simply do an Euclidean distance. I have implemented that in Unity, and you can see I have put the hand size in width pix, so the width of the hands in pixel values. So now we have the hand size. Now we will jump into something a little bit more complex, the relationship between the hand size and the Z coordinates. For that, I have decided to use a linear function, a times x plus b, where a can be represented as the slope and b as the constant, and x of the inputs, in our case, the hand size. But we are not done yet. We need to define that linear function if we want to use it. How? Well, with linear functions, that's so easy. We only need 2 examples. Let me explain. So we will need to define 2 points, one with the hand at the middle, and one, I will bring my hand very close to the camera so the webcam can barely detect it, and a little bit before that, that will be the maximum position. I'll actually run the Unity code, you can debug that with this line, and it is very important to note these values down, as we will use them to define the linear function. First, I will run the Python scripts. Okay, so now the Python code is running, it can detect the hands. Now we can proceed. I will run the Unity script now and also open this console. Okay, now you can see that it is debugging, it is capturing different size. If I bring my hand closer, the size will be bigger because it will have a larger width in the pixels. So now I will define it. So this will be my default value. As you can see, it is approximately, okay, I'll just bring it a little bit closer. It will be, I'll say 150. Now I will bring my hand to my maximum. I will bring very close to the webcam so that it can barely detect it. Okay, I think that's too close. Okay, I don't think I will go beyond this point anyway. So I will say 550. So now, as I have said, I will mark those down. I'll just write in the code. Okay, so the middle width or middle size, whatever you want to call it, will be 150. And for the Z value is equal to 0. And for the max width or max size, it will be 550. This obviously depends on your environment, on your placement, and also on your webcam as well. And now, another important thing. So now we have the inputs. Now let's focus on the outputs. So for the first outputs, as I have said, this will be at the middle. So I have set the Z to 0. Now we need to focus where the Z should be when the hand is at its maximum. In my case, as you can see, I will not go beyond this white square, this white cube. This is my game environment, and I know that this is 40 by 40, but if we start from the origin, from the middle, it will be 20 to reach the edge. So in my case, z will be 20 then. Now we have the examples. Now let's compute the linear function. First, we compute the slope, and the slope is defined by this following math formula. First output minus second output, all divided by first input divided by second input, which is in our case is 0 minus 20 divided by 150 minus 550. And now we only need to compute those values. 0.05. That's the slope we want. Now we want to set the constant value. And this can be done with only one example because we have the slope already. So we can take the first example, for example. This is the easiest because the output is actually 0. So this is a very basic equation with only one unknown, which is the b, the constant value. It will be 0.05 multiplied by 150, the input corresponding to z to 0, plus b equals to 0. And if we compute that, b will be 7.5. Now we have the linear function, 0.05 multiplied by the hand size in the pixels, plus 7.5. And with that relationship, that will represent the z coordinate of the whole hand. And now let's do that. So I will call it float z hand equals to 0.075 multiplied by the hand width pix plus 7.7. Actually, you don't need to compute your own linear function. You can just automate the process, which I have done manually in this video. I just wanted to make sure that to map the relationship between the hand size and the z coordinates. Let me fix the typo here. And now we need to do another thing. I have set this game object as, I will call it whole hand. Let me go back in Unity. As you can remember, all the balls are children of one empty object. And the beauty with that empty object in Unity, if we move that empty object, all its children will move as well. And that whole hand is the object that we will move along the z-axis. We don't need to move all the landmarks into the z-axis. We can just move the parents of those landmarks. So we do whole hand dot transform dot position equals to new vector 0, 0, 0. And here I will put the hand. There is no need to define the x and the y because in each landmarks individually will do that very well. Yeah, just make sure that you put an f, a lowercase f, inside all the number that are decimal number. This is just how Unity works. Well, actually, C# works. Before we run that, make sure that we include the balls into the whole hand. Now we run it, and there you go. Now that's actually very beautiful. Okay, I will try with my left hand. Now we can see that it is going well on the z axis, but there is a small problem. Did you notice it? So this is the issue. The size is still changing. Yes, it is moving well along the z axis. However, it is still changing, just as it was before we could move it along the z axis. How to fix that? Easy. With a little bit of math. Don't worry, it is going to be less complicated than the linear function. Why does it change the size itself? Well, remember that I have once said in this video that the hand size in the pixel values can vary in the webcam. And this is what is causing this effect. You need to consider this. We have a set size. I haven't explicitly defined that, so I'm assuming in our case it is 1. And we have the hand size into the pixels. And Unity actually multiplies them together. So to bypass this issue, we need to divide this whole thing into the size in pixels that we have calculated earlier. Let me show you. So I have predefined this here. Yes, we need to type this float equals float hand size equals 200 divided by the width pix, the hand size in pixels. And we can actually pick anything between 200, it could be 100 or 500, it depends on your case. And just like as we did with the position, remember for the position, I have said that if anything moves from the empty point, every children of that point moves as well. It is the same for the scaling as well. If we change the scale, we change everything scales by considering the object as the origin. And this is what I have done. So the whole hand will change the local scale by this new vector, which is composed of the hand size we have just computed. Now let's save this file. Oops, sorry. And let's run Unity again. Let me put this in full screen. As you can see, the size of the hand is not changing itself. Yes, you can see that. However, I said hands, not components of the hands. Yes, there is a third issue. I promise, this is the last issue of this video. As you could see, the landmark sizes were changing when I bring my hands forward and backwards. And that is due to the same problem with the whole hand. The size is not normalized. And how to fix it? Well, since we have the same issue, some solution. We can set the scale of each landmarks, and we need to divide by the hand size. Let's save this. Let's run it again. And there we are. Now, all the problems in this video are fixed. It is moving in a Z direction. It is not changing the size, and even the landmarks are not changing the sizes. Well, that comes the end of this video. We haven't only finished the tutorial, but also the series. If you have followed along and have coded a similar project, please let me know down in the comments. And don't hesitate to contact me on the social media or via the comments below if you have any questions, and see you in the next video.